All right, so when you're finding the x and y intercept with numbers 4 and 5, what did you have to do? Mm-hmm. Plug in 0 for what?
I started with y.
Okay, so if you plug in 0 for y, that means you're finding the x-intercept, and if you plug in 0 for x, you're finding the y-intercept. And then once you get your answers, you plot them, and those 2 points should form a line. So what we're going to talk about today is we're going to talk about slope. What is slope? What is slope? What do you mean shaped like this? It's like a diagonal line? Okay. All right, and what does slope tell you? Yeah, the rise of a run. So slope is the rate of change between the rise on a graph and the run on a graph. So we'll talk today first about rate of change. Rate of change is just a ratio that compares the amount of change in the dependent variable to the amount of change in the independent variable. So for example, if you are mowing lawns, there was a question on your test about mowing lawns, right? Philip charged $25 per lawn to mow a lawn. And if you're looking for a rate of change, you would create something like this. So you'd say like number of lawns and then amount of money that he made. And if he mows one lawn and gets $25, if he mows 2 lawns, how much would he get? 50. If he mows 3 lawns, how much would he get? And so on and so forth, right? So this would be 4, this would be 100. So if you're looking for a rate of change, you're looking for the amount that the dependent variable changes over the amount that the independent variable changes. So the first thing you have to determine is which is your dependent and which is your independent. So in number of lawns and money that he makes, which one of those is independent? Which one of those is the independent variable? Number of lawns. The number of lawns is the independent variable because the amount of money that he makes depends on the number of lawns that he mows. So the independent variable goes at the bottom and the dependent variable goes at the top. So the first thing you want to figure out is what is the change? What's the change in the independent variable? Well, for the dependent variable, again, dependent, we're talking about the amount of money he makes. What's the change from 25 to 50? And from 50 to 75? And from 75 to 100. So is it a constant rate of change? Yes. So then that would go on the bottom. The independent that would go on the top. The change in the dependent variable is 25. And then what's the change in the independent variable? It's going up by 1. All right? So the rate of change then would be 25 over 1. All right, so 25 over 1. Could you just write that as 25? Yes, but because we're talking about a ratio, a lot of times we want to keep that 1 in there as a placeholder so that we know that that rate of change is actually 1 because the number of lawns he mows does go up. Okay, so this table shows the cost of mailing a 1-ounce letter in different years. Find the rate of change in cost for each time interval. During which time interval did the cost increase at the greatest rate? So there's 2 things that we have to do here, and we're going to start with the first part. But before we do that, again, remember, rate of change is, this symbol right here is called delta, just means change, all right? So this symbol is delta, it's the Greek letter delta, and it means change. So we'd say change in y over change in x, or you'd say change in dependent over change in independent. So right here, we've got the year and we've got the cost. And again, if it's a change in y over change in x, which one of those actually goes on top? Which one of these is my dependent variable? Which one of them is my independent variable? The year or the cost? Which one is independent? Independent is the year, all right? So this is my x, and the dependent is the cost, so that's my y. So despite how the table is set up, which one actually goes on top? The cost, right? The y actually goes on top. So if the cost is 22, we're looking for the rate of change. So what's the rate of change from 22 to 25? Plus 3. What's the rate of change in years at that time? Plus 3. So the rate of change from 1985 to 1988 would be 3 over 3. All right, because you changed 3 cents and 3 years. What does that reduce to? 1 over 1. All right, what about 1988 to 1990? So we're going from right here to right here. Which of these goes on top? The y goes on top. What's the change from 25 to 25? None. 0. All right. How many years was there? 2. So then that would be 2. What's 0 divided by anything? 0. All right. So the rate of change there is 0. What about 90 to 91? 1 year. And how much money? 4. Which one goes on top? 4. So 4 over 1. And then last but not least, 91 to 2004. How many years is that? 13 years. And how much money? 8. So how do I write that one? 8 over 13. Okay. Which of these is the greatest rate? Which of those is the greatest? Alejandra? It looks like 1991 to 2004 would be the greatest rate because it went up how much? 8. However, why is that not actually the greatest rate of change? Angel? It's less than 1. This fraction right here, 8 out of 13, is less than 1. It's like having a pizza with 13 slices and you get to eat 8 of them, which is a lot of slices of pizza, right? But it's not the whole pizza. What about this one, 1990 to 1991? That's like having how many whole pizzas? 4. That's like you having 4 whole pizzas to yourself. So this is the greatest rate of change. But why is that? Why, when you look at this, why is this deceiving? When you first look at the rate of change, it looks like this would be the biggest one because it's 8 cents. However, why is it not really that much? Why is that kind of deceiving? Because it took how many years to go up that many cents? 13. So really, it's not even like, that's less than a cent a year, right? Whereas what happened from 1990 to 1991? It went up 4 cents in how many years? Just 1 year. So the duration was a lot shorter. Therefore, this is our greatest rate of change. So the greatest rate of change ends up being this one because it's the biggest number. And again, this number here, 8 over 13, is less than 1. Whereas this one is equal to 4. So the biggest thing to remember with rate of change is that it's change in y over change in x. So more often than not, if it's given to you in a table, what are you actually going to do with the numbers? Flip them, okay? Because x is your independent variable and y is your dependent variable. And you want the dependent variable on top. Okay, what about if I give you a graph and ask you to find the rate of change? There's a couple ways you could do this. Could you record that information in a table? Yeah, absolutely, you could record it in a table, all right? Or you can just kind of count from point to point. So what's our first of all, what's our independent variable? Years, right? Years is our independent variable, so that's going to go on the top or the bottom? Bottom. And then what's our dependent variable? Cost. All right, so this is going to go on the top. That one would go on the top. Good. This is exactly the information that we just looked at. So we're going to go through it, but you guys have seen all this data before. So the first one, here, this first point, is at what year? Where's the second point? 1988. Something like that, right? I think if you look back at your table, it's 1998 or 1988. So you're going up 3 cents over 3 years. So that's where we got the 1 over 1 from the first one. So if we go back to this, all of this data would be 3 over 3 is equal to 1. So our first rate of change is 3 up and then 3 over. The next rate of change only goes over 1, but how many did it go up? 4. The next one goes over how many? Goes over 13 years, but it only went up 8 over the course of that. So this is just a graph of the information that we had in the table before. So if you're going to find a rate of change from the graph, what you're doing is, like Ashley said at the very beginning when we said slope, what is slope? Slope is rise over run. So you figure out how much you count up, and then how much you go over. All right, so it's how much you go up and then how much you go over. So that's exactly what slope is. Slope is a constant rate of change, so it's a constant ratio of change from one point on a line to another point on a line. And we use rise over run to establish the delta y over delta x that we talked about a minute ago. Is just rise over run, because the y-axis goes which way, up or down? Up. So it goes up or down, I'm sorry, up or down or over. It goes up and down, right? And then the x-axis goes which way? Horizontal, so left and right. So when we say rise, that means how much do you rise, go up or down, all right? And how much do you run is how much you go left or right, all right? So when you're talking about slope, you're just talking about how much you go up or down versus how much you go over. If you go down, what's the difference between going down or up? What does your number look like? If you're going down, it's negative. If you're going up, it's positive. If you're going right, your number is positive. If you're going left, your number is negative. Okay, so how would you find the slope of this line then? How would you find the slope of this line? Remember that slope is rise over run. So how can I find the slope here? Diego?
So you go from one point up,
Mm-hmm.
and then you get the 1 and -4. The point right there. You go up.
So you're starting at this point?
Yeah.
Okay.
So you go up 1, and then over.
Well, I want to go from this point all the way to here, right?
And then you just keep it.
So I got to figure out how much I go up. So I go up 1. So how much did I go up? 7. And then I've got to figure out how much I go over. 7. But because I went that way, it's going to be a -7. What does that reduce to? -1 over 1, or just -1. Okay? Now, I'm going to recommend, this is what I always do, you definitely don't have to do it. Could we have started at this point? If I started here, do I go up or down? Down. 1, 2, 3, 4, 5, 6, 7, and then what? 1, 2, 3, 4, 5, 6, 7. So my slope here would be what? -7 over 7, which still reduces to what? -1. Okay? So it doesn't matter which point you start with. So Diego started with this one, I started with this one. Did we get the same slope? Yes, we got the same slope. Okay? The important thing to remember is that this is a negative slope. We'll talk about that in just a second. All right? So it does not matter which is which. As long as one of the numbers is negative, that means the whole thing is negative. All right? If both of them were negative, what would happen? It becomes positive. Good. Okay? So it does not matter which point you go from. I just always start with the one on the left. Okay? So I will always do the one further left, but it doesn't matter. Okay, questions on how to find slope from a graph? All right, you're going to do these 6 at your boards. Hang on before you get up. These, I know it's going to be hard to see from your seats, so just do your best to try to count them, but if you need to come up to the board, you can. Just don't crush each other up here. Okay, so the biggest thing I would say with this is just make sure you're careful that you're doing your rise before you do your run. Some people did their x's before their y's. So y always goes on top. The dependent variable goes on top. The independent on the bottom. Okay. What are the slope of horizontal and vertical lines? What's the rise and run? So we did this one, this blue one. We did this in the practice problems that you just did. What was the slope of this line? 0 over 1, which is the same as just what? 0. Okay, the slope of a horizontal line is always going to be what? Always going to be 0. Because do you ever rise? No. All right, so there is no rise for a horizontal line. which means the slope will always be 0. What about a vertical line? What about a vertical line? Like this one, for instance. Let's say this were a point on the line, and this were a point on the line. How much do I, yeah, there is no run, right? So that means what would go on the bottom? 0? Can you do that? Can you have 0 in the bottom of a fraction? No. So what does that mean? What is the slope of a vertical line? Brendan, what's the slope of a vertical line? Undefined. It's undefined. So that word means, what does undefined mean? It's not defined. So what do you think that means? To be not defined, what do you think that means? Yeah, well, there isn't anything, you can't do it. There isn't a definition for it because it's not something that makes sense because you're not allowed to have 0 in the denominator of a fraction. You cannot divide by 0. All right? Division is like, let's say I had a group of 20, how many of you are there? 22 students, right? And I said, let's pretend there's 20 of you. Let's say I had a group of 20 students, and I said, get in groups of 4. What would you do? There would be 5 groups, right? What if I said, get in groups of 0?
No groups.
You can't do that. You can't be in a group of 0. You cannot divide by 0, all right? You can't divide by 0, which is why you can't have 0 in the denominator of a fraction. Therefore, there is no slope of a vertical line. It's undefined. Now, all right, I'm going to introduce you guys to my best friend. His name is Slope Dude, all right? I am really obsessed with this video, and I show it every year. I think it was made in like 1982, and it's really good. What? It's going to be awesome, all right? It's going to be really awesome, but I'm going to pause this. There are a couple things that I really like about Slope Dude. The first is his soothing voice, all right? The second is that yeah, it doesn't change the whole time. And my second favorite thing is that he makes a couple mistakes while he's recording the video, which makes me think that this was like the 10th take because he was like, I just got to go with this one. So even though he made a couple mistakes, he still went with it. So I know this video is ridiculous, and you're probably like, why did we just waste 2 minutes of our life? But I think that it really helps to remember because people make this mistake all the time. If your line is going uphill, then your slope should be what? Positive. If your line is going downhill, it should be what? Negative. If your line is going horizontally, you're not having any fun. It would not be fun to ski on a horizontal flat surface, all right? That is 0 fun. The slope is 0. And then the last one, undefined. Slope Dude, RIP Slope Dude, he fell off the mountain, okay? Undefined. As you go down a vertical line, it is undefined. The other really important, what?
Did they ever find the body?
No, they didn't find the body. Well, no, he popped right back up.
Well, I mean, he lives on as the mountain, but I mean...
He lives on as the mountain. I don't know what happened to Slope Dude, but here he is. Okay, so the last thing that he said, at the very beginning, he said he always skis from east to west. No, eastward. So he goes towards the east, right? So he is always skiing from left to right, which means when you are trying to find the slope of a line, don't look at it from right to left. You've got to look at it from left to right. So,
The uphills.
all right. So that's Slope Dude. Now, I want you guys to, at your boards, describe the slope of each line as positive, negative, 0, or undefined. For positive and negative, you can just put plus or minus. That's fine.
The uphills